Hello students, today's lesson is on solving radical equations. So there are some steps that I want you to follow, so let's go ahead and write those down. When you're solving radical equations, the steps that I want you to follow are: number one, you need to isolate the radical, okay? So that just means that you want to get the radical completely by itself. Okay? Then depending on what your radical is, if it's a square root, then you're going to square both sides. If it's a cube root, then you would cube both sides. So basically, you're going to do the inverse operation to get rid of the radical, okay? And then from there, you're just going to solve it, which anytime we say solve, that means that you're trying to figure out what the variable is, so you're getting the variable by itself, okay? Alright, so let's look at an example. I'm going to do example 1. And let's say we have the square root of x plus 3, and that's equal to 7. Okay? So the first thing that you're going to do is, of course, make sure that the radical is completely by itself on one side of the equation, and it is. And then you're going to do the inverse operation. Well, because this is a square root, then that means that you are going to square both sides to get rid of it. Okay? And that cancels, so you'll have x plus 3, and that equals 7, sorry, forgot my squared there, 7 squared, which is 49, and then now you solve it by getting that x by itself, so you have to subtract 3, so x is equal to 46. Okay, so the next example, we have the square root of x plus 4 minus 6 equals 3. So we need to isolate the radical, which means we're going to have to add 6 to the other side. So we have the square root of x plus 4, and that equals 9. Okay, so it's a square root, so we want to do the inverse operation, which is square it both sides. So that's going to give us x plus 4 on the left, and then 9 squared, which is 81. And then we subtract 4 from both sides to get our x by itself, so x is equal to 77. Okay, and let me point out here that if you want to check your answer, you can plug in that 77 in for x and see if that gets you the correct answer. One thing I will point out tomorrow is I will show you how you can check your answer by using your graphing calculator. Alright, next example, we want to isolate the variable. The variable is, not the variable, I'm sorry, the radical. The radical is not by itself, so we need to divide both sides by 4 to get that radical completely by itself. So we're going to have the cube root of 2x minus 3, and that equals 3. Okay? Well, this time, because we have a cube root, the inverse operation is to cube both sides. Okay? So that cancels. And we have 2x minus 3 equals 3 to the 3rd power is 27. Okay? Then we're going to solve for x. So we're going to add 3, and then 2x equals 30, and divide by 2, x equals 15. Okay? Again, you can check your answer by plugging it in for x to see if that is correct. Okay, next example takes a concept that you learned in the last night's video, which is these rational exponents. When you have something raised to the 1/2 power, just remember that is the same thing as the square root of 5x plus 4. So anytime you have something raised to the 1/2 power, that's the square root. If you have 1/3, then that's the cube root. If you have it raised up to the 1/4 power, that would be the 4th root, and so on and so forth. Okay? So in order to get rid of the radical, it's isolated, so we're just going to get rid of it by squaring both sides. And of course, if you recognize that this power is the square root, you could just go ahead and square both sides from this point. The other thing I want you to recognize is that if I was to square this, because you have a power to a power, 1/2 times 2 is just 1, and that's the other reason why that gets rid of that. So we have 5x plus 4, and it's equal to 16. So we're going to subtract 4. So 5x equals 12, and then divide by 5, and that ends up being 2.4. Okay? And again, you could check your answer. Okay, next problem. 18 equals 3 pi times the square root of x. Isolate your radical by dividing both sides by 3 pi. 3 pi is just a number, but we write it as a symbol so we don't have to round it. That's going to cancel here, so you're going to have the radical x on the right side. 18 divided by 3 pi is approximately 1.9098 if you do that on your calculator. Okay, and then to get rid of a square root, of course, we're going to square both sides. Okay, so x equals, that comes out to be approximately 3.65. Okay, this is important because we're going to use a formula here in a minute, which you'll need to know how to divide by pi and all of that. Okay, I'm going to write down this next example, and I want you to try it on your own, and pause the video. After you've worked the problem, press play again, and let's see if you got the same thing that I did. Alright, so here's the problem. Okay, so we have 3.4 equals pi times the square root of x divided by 5. So I want you to try it and then press play when you're ready to check your answer. Okay, so I got 5.86 for my answer, so let's check what I did. So the first thing I did was I divided by the pi on both sides, okay? And so that gives me approximately 1.08, and then I have the square root of x divided by 5. To get rid of the square root, I'm going to square both sides, okay? And that gives me approximately 1.171, and that's equal to the x over 5. To get rid of the divided by 5, it's divided by 5, so the inverse operation is multiply by 5. So I'm going to multiply by 5 on both sides, and I get approximately 5.86. Okay, for the next problem, I'm going to use some physics here. So if you're in physics, maybe you've seen this before. If you're not in physics, you'll see this eventually. We have in physics what's called the pendulum formula. Okay, this is when you are making a pendulum go back and forth. You can calculate the length of the pendulum, the period of the pendulum, and so this is just a formula that we use, and here's the formula. It's P equals 2 pi times the square root of L divided by G. Okay, now P is what we call the period. I'm not going to go into detail with that. You can ask your physics teacher about that. The L is the length of the pendulum, and then G is the gravitational acceleration, I believe is what it is. Well, it's the gravitational force. I couldn't remember if it was, yeah. So gravitational force. All right, so if I'm given a few things, so let's say in this problem, I'm given, of course we know what the gravitational force is, or you will if you're in physics, it's 9.8, okay? And in this particular problem, we're going to say that the period is equal to 1.2, and we want to find out what the L is equal to, okay? So you're going to go ahead and plug those in. So let's do that. So we're going to have 1.2 equals 2 pi times the square root of, since we're trying to find the L, we're just going to leave L there, but we're going to put 9.8 in for the gravitational force, okay? Well, now you have to use your algebra in order to solve for L. You're going to, first thing you're going to do is you're going to divide by that 2 pi because you want to get your radical by itself, okay? And so that's going to give us approximately 0.19, and that's equal to the square root of L divided by 9.8. And then to get rid of our radical, we're going to square it, okay, which gives you 0.036, and that's equal to just L divided by 9.8. And then, of course, to get rid of a divided by 9.8, then you want to multiply by 9.8. Okay, so I'm going to write my answer over here. That means that the L is equal to 0.36. Okay, so this just gives you an example of how you might use these algebra skills later on. And so hopefully this has been helpful and you know how to solve radical equations, and I'll see you tomorrow when we work some problems.